Hi, everyone. Can you all see the whiteboard?
Yes.
Okay, what are your answers for the first question? Okay, good. 5 is correct. Preeti, can you explain?
Uh, yeah, so what I did was I made a system of equations where I did 5x plus 10y equals 85. And then I wrote x plus y equals 12. And then I just solved for y because it asked how many 10 cents. And then I got y equals 5.
Good. And how did you know that 5x plus 10y was 85?
Because I did that there was 5 cents and 17 coins, so I did 5 times 17 to get that.
Good. Yeah, so I think the key piece here is that you want there to be 17 different values that can be obtained by combining 5-cent and 10-cent coins. And I think the main thing to see here is that when you have at least one 5-cent coin and the remaining 10-cent coins, you can make any multiple of 5, right? Because first you can do 5, then use a 10 to make 10, then 10 plus the 5 to make 15, and so on. And you can only make multiples of 5, right? Because the 5-cent and 10-cent coins are both multiples of 5. So the 17 different values must all be multiples of 5. And if we assume that we have at least one 5-cent coin, which must be true, since if they're all 10-cent coins, we can actually make 17 values, then we can make kind of every multiple of 5 in between. So if there's 17 different values that we can make, that must be 17 times 5 are the values. So 7, 5, 10, 15, and so on. So the total must actually be 17 times 5. So we know that the total value of the coins is 85. And number of coins is 12. So then it just comes down to figuring out how many are 5-cent and how many are 10-cent coins. So we know there's 12 coins. So one way is like Preeti said, if you make x the number of 5-cent coins, y the number of 10-cent coins, you can do x plus y is equal to 12, and then 5x plus 10y is 85, and solve the two equations to get y equals 5. The other way is, so let's say if all the coins were 10-cent coins, what would be the total value? Would be 120, right? So if one of those became a 5-cent coin, then it would be 115. So we want it to actually be 85. So how many coins do we have to change from being 10-cent coins to 5-cent coins to bring it down to 85?
Seven.
Good, 7. So 5 times 10 plus 7 times 5 gives us 85. So then we know there's 5 10-cent coins and 7 5-cent coins. So so Claudia has 5 10-cent coins. Any questions on this? Okay, let's move on to the next question. Okay, 8 is correct. Vedant, can you explain?
Yeah, so since it's not 1 or 0, the only values could be 2, 3, 4, 5, 6, 7, 8, or 9. So find out number of combinations I did. There's 7 letters. Find the number of combinations I did. 8 factorial over 7 factorial. And I got 8. The answer.
Good. Yep. So there's 8 possible choices of digits that could fit here, right? Because 0 or 1 are not possible. So it's any of the digits 2 through 9 that can take the values for A through G. So now we basically want to choose 7 of them. And for just a phone number, order does matter. But because we know that the digits are increasing order, it's essentially like once we pick 7 of the digits here, they'll fit A, B, C, D, E, F, G in increasing order. So the order is fixed once we choose which are the 7 digits here. And choosing 7 digits from this 8. So one way of doing this is 8 choose 7. Another way is there's 8 digits and we only want 7 of them, right? So this is equivalent to removing 1 digit. So removing 1 digit, there's 8 choices for the digit to remove. So there's 8 different telephone numbers that David can have corresponding to removing either 2, 3, 4, up to 9. We can remove any of these. And does this make sense? Any questions on this? Okay, let's move on to the last question. Any answers for this question? Okay, Sanvi, how did you get 32?
So what I did was, if the radius is 4 feet, then the area of the circle, it'll be 4 squared times pi, which is 16 pi. And so if the area is 16 pi and you have a it's filled with water to a depth of 2 feet, you would just do 16 pi times 2 feet. I didn't put the units, but I got 32.
I see. Okay. So 16 pi is good. That is the area of the circle, but I think we have to be a little bit careful when we actually compute the volume of the water. So basically 16 pi is this area, right? So this is the cylinder. Sorry, the picture is not very clear, but let's say this is the base of the cylinder, and this is the height. So we know that this radius is 4. Let's say that's the center of the circle. Or I'll put the radius in this way. So we know this radius is 4. Now the water level is actually, imagine this on the ground, the water level is actually here somewhere, right? So this is kind of the water here with this height being 2, right?
Yeah.
And so kind of if I were just asking the volume of the cylinder, right, I could just take the area of this base and multiply it by this height. So this would just be 16 pi times 9 if I wanted the full volume. Now the problem is that I actually don't want the full volume. I want basically taking this area here and multiplying it by the height. And that would be the volume that the water takes up, because the water is not actually filling the whole cylinder. It's only filling this part of the cylinder, like by this arc, and then the height of the water, which is 2 feet above the ground. So I'll mark this. What is 2 is this line. Okay, so now we need to find the area of this region. Any ideas of how to find this area?
You could try figuring out how that area is proportionate to the rest of the circle.
Good. Yep.
Multiply it by nine.
Now we want to do that, but the issue is that first, this is not a portion of the circle yet, right? I have to connect this to the center and this to the center. And now I have an arc of the circle, right? But I just need to remove this triangle here. So now what I can express this area as is this arc, or this kind of portion of the circle, minus this triangle. So now we need to figure out what is the area of this region of the circle and what is the area of this triangle. So let's write down some more lengths that we know. So what is this length of this side of the triangle?
4.
Good. And what about this one?
4 also.
And what about the height of this triangle?
2.
Good. Okay, let's draw that in. So I'll draw in the height here. This is 4. This is 4. This is 2. Okay, so what kind of triangle is this?
That is an isosceles.
It's not isosceles since we don't know necessarily if it's isosceles, but yeah.
After a right triangle.
Yeah, first good. It's a right triangle. And Preeti said 30, 60, 90. It's also that good. So yeah, the first step we need to see this is a right triangle because this is perpendicular to this, right? So this is a right triangle. And the next step that we need to know is this is a 30, 60, 90 triangle. So this is something, there's some properties of certain triangles. When they have some ratios of their sides for a right triangle, you also know their angles. And so there's two main ones that are good to know. So one is the isosceles, a 45, 45, 90 triangle. So this triangle looks like this. You have a right angle, and these two sides are both the same. So this is, let's say, A, and this is A. So this is an isosceles right triangle. And then this from Pythagorean theorem, you can do this would be A square root of 2. And another triangle is a 30, 60, 90 triangle. And the way to determine that, I'll show you the ratio of the sides in a second. So this is, let's say this side is A. This side would be 2A. And this side would be A times the square root of 3. So any multiple of these side lengths are similar to the same triangle. And this angle is 30 degrees. And this angle is 60 degrees. Okay, so in this case, we actually see that this side length, the hypotenuse, is double this side length. So this is actually also a 30, 60, 90 triangle. And you can confirm this if you apply the Pythagorean theorem. Here, we can see this squared minus this squared minus this squared will be this squared. So we can do that. This is 16 minus 4 is 12. So the square root of 12 would be this side, which is 2 square root of 3. So now we know this is a 30, 60, 90 triangle. We can see the ratio of the sides. So this is, if we take A is 2 here, this is 2. This is 2 times the square root of 3, and this is 4. So it matches the same ratio of the sides. So thus it must be a 30, 60, 90 triangle. Now, this helps us in two ways. So one is we know what this angle is now. So this angle is 60. So now we can find the areas of both the pieces we need. We can find the area of the circle region as well as the triangle. So let's start off. What is the area of this region of the circle?
Can you repeat the question?
Sure. What is the area of this region of the circle? So we know the angle of 60 degrees. Yeah, go ahead.
So if that's 60 degrees, then the other half of the triangle will be 60 degrees, which is 120, which is 1/3 of the circle. So if the area is 16 pi, then all you have to do is divide it by 3, which is 16/3 pi.
Good. Yep. 16 pi over 3. And then we can now subtract the area of the triangle. So what is the area of the triangle here?
It is 2 square root 3. Wait, no, that would be. Well, for 1/2 of the triangle, it would be 2 square root 3 times 2 divided by 2, which is the same thing as just 2 square root 3.
Yep. And we want to count that twice, right?
Mm-hmm.
So we want a total of 4 square root of 3, right? So this is 2 square root of 3 times 2 divided by 2 is this area. So this area is 2 square root of 3. And this side is 2 square root of 3. So we want to subtract from the 16 pi over 3 minus 4 square roots of 3. Okay, so now we actually have solved for this area. The area of basically the water, if I just looked at one side of the tank. So now what do we have to do to get the volume of the water in the tank?
Now what you can do is multiply it by 9
Good.
feet, since that's how long it would be, since it's on its side.
Good. Yep. And what do we get when we do that?
.48 pi minus 36 square root 3.
Good. Yep. And this is actually the answer. 48 pi minus 36 square root of 3. So there's a couple of things to know here. One was, so first we have to look at when the depth is 2, it looks like this. The region, so it's kind of a sector of the circle minus this triangle is kind of what the water looks like on one side, and then you have to multiply that by the height to get the volume. But now to find this area, you have to take kind of the sector of the circle minus this triangle. To do that, we know the side lengths here. We know this is a right triangle, we can compute this side, and then you had to know this property for a 30, 60, 90 triangle to get this angle. But otherwise, you could still find the area of the triangle at least and express it in terms of the sector of the circle minus this triangle. And then, but knowing this angle helps you actually find the area of this circle piece. And then the circle minus the triangle gives us this area. Multiplying this area by the height gives us the volume here of 48 pi minus 36 square root of 3. Any questions on this? So the general relations here between the angles in this right triangle and the side lengths is actually part of trigonometry. But the 45, 45, 90 and 30, 60, 90 are kind of simpler and usually taught earlier in geometry classes. So if you haven't seen this already, you will probably see it if you take geometry in school. But these are still good to know. This relationships for a 45, 45, 90 triangle. This is an isosceles right triangle, as well as this 30, 60, 90 triangle. They're easy to describe the relationships between the side lengths, and they can be useful when you see those kind of patterns in a right triangle. Any questions on this? Okay, then that's it for today's class. We'll see you all next week.
Thank you.
Thank you.
Bye.
Bye.